Greetings, aspirants. Hope you all are doing well. Welcome to another video of CC Concepts of the subject Science and Technology. And today in this video, we are going to talk about controlled and uncontrolled and controlled chain reactions. Now, when we are talking about chain reactions, we are talking about the nuclear fission reactions. Now, let me first briefly explain what happens in a chain reaction, or what happens in a nuclear fission reaction. Firstly, a neutron is going to collide with the uranium-235 atom. Now, once it collides, it's going to form a unstable nucleus. It's going to form a unstable nucleus. Now, this nucleus, to attain stability, it is going to give you two atoms, which is kryptonium and barium. And at the same time, a lot of energy is going to release, and we are going to get three neutrons. Now, this is what happens in a nuclear fission reaction. Now, how does chain reaction come into play from this? Now, the neutrons, extra neutrons which we are getting here, they are going to combine with other uranium atoms again, and this reaction is going to continue. So, this is how a chain reaction happens. Now, in simple terms, to define the chain reaction, it is any nuclear reaction in nuclear physics, in any process during which the nuclear fission reactions become self-sustaining because they don't need any other interference further, right? In other words, one fission reaction can induce another without any further intervention. How is that going to happen? Just look at this example. Now, initial neutron is going to combine with the uranium nuclei. Then here, how is it going to become self-sustaining is that these extra neutrons are going to be absorbed, because if they are not going to be absorbed, they'll be the reaction rate would be at the fastest, and because of the tremendous amount of energy, we won't be able to control it. Now, for it to be controlled, we have to absorb the extra neutrons. Once you absorb the extra neutrons, the neutron which comes out of this reaction as an outcome is going to bombard with another uranium nuclei. That's how absorbing the extra nuclei, this reaction is going to be controlled reaction, or it can be, you can say it's a chain reaction. Now, what is a critical reaction? So I told you that each fission reaction produces exactly one further fission reaction and maintains the constant rate. But these kind of things doesn't happen in the fission reaction. We are going to get more than one neutron, but we are talking about that reaction where each fission reaction produces exactly one further fission reaction and maintains the constant rate, of reaction, neither decreasing nor increasing. So that has become self-sustaining, and thus such reaction is called a critical reaction. So this kind of perfect reaction where each fission reaction produces exactly one further fission reaction is called as the critical reaction, and the amount of fissionable material used to facilitate this exactly one extra fission reaction for one-to-one sustainability is called the critical mass, which means the smallest amount of mass that will facilitate the sustained chain reaction. So this is what we call the critical material, and that is what we call the critical reaction. Now, moving forward, this is what happens in a uncontrolled chain reaction. So we are going to have a neutron bombarded with uranium. We are going to get two extra atoms. We are going to get two extra atoms, which are krypton and barium. And along with that, we are going to get energy, and we are going to get three extra neutrons. What if these two extra neutrons, which came up as an outcome, are going to react with uranium again? It's going to lead to a reaction like that. So this keeps on happening, and at some point of time, we won't be able to control it. Here the rate of reaction which we talked about is kept on increasing. This was increasing. So this makes it an uncontrolled chain reaction. So these kind of reaction occurs when more than one further fusion reaction is induced by the neutrons emitted from the fusion, unlike the critical reaction where only one further fusion was possible. So the amount of fissionable material required to facilitate this an uncontrolled chain must exceed the critical mass, because what I told you, critical mass is exactly that mass which will facilitate only one further fission reaction. But for this uncontrolled chain reaction to happen, the fissionable material which we are going to take should be having more than the mass of the critical mass, right? Now the rate of fission and the power of the uncontrolled chain reaction are exponentially increasing. They keep on exponentially increasing. That's why the rate of reaction also kept on increasing. As a result, the uncontrolled chain reaction are seen as the use of nuclear weapons, whereas the control chain reactions, we are going to use it in the nuclear facilities to generate power. These kind of things, this kind of nuclear fusion or uncontrolled chain reaction is used in the nuclear bombs. At the same time, for this, the moderators are used. Now, what is the purpose of these moderators? The purpose of moderators is to moderate the reaction through by moderating the speed of neutrons, which we'll talk about later. So, moderators are used in the uncontrolled chain reactions to increase the likelihood of successful fission. Control rods are not used. Now, the control rods take away the extra neutrons which we are getting and makes it a controlled chain reaction. Whereas the moderators are used in both controlled and uncontrolled nuclear fission reactions, because these moderators are going to increase the efficiency of the working of the cycle, right? Now, whereas the controlled chain reaction refers to a chain reaction whose rate of fission is controlled, means the rate of reaction does not increase. Rate of reaction does not increase, it's controlled, and the generated energy is also controlled. Thus, a controlled chain reaction allows for the fission to occur in a self-generating manner while limiting the amount of energy produced. At the same time, we keeping us safe from the uncontrolled environment. So the rate of fission and the power of the controlled chain reaction is constant and can be controlled with the use of moderators and also control rods. As a result, the controlled chain reactions are used in the nuclear power plants, whereas the uncontrolled chain reactions are going to be used in the nuclear bombs. Now, what do we require in a controlled chain reaction? There are three main components of the controlled chain reaction which are necessary. The first one being fissionable material that meets the critical mass, because we need the reaction to be sustaining. For it to be sustaining, we need to have at least the critical mass so that it leads to at least one more reaction, right? Then we have the control rods. Now, what are the control rods are going to do? These control rods are going to absorb of the excess neutrons, which will be leading us to uncontrolled chain reaction. Because as I told you earlier in this video, the excess neutrons which are going to come are going to react with the uranium again, right? So that's why the control rods takes away the excess neutrons. And lastly, we are going to need the moderator. Now, what is the purpose of the moderator? See, well, for this reaction to happen in a chain, the neutrons which are coming out, they should be again absorbed at the right speed. But these neutrons which are coming after the first fission reaction, they are either too fast or either too slow. And mostly because of the force which was created, they are going to be too fast that the reaction won't be able to happen. The reaction won't be able to happen or proceed, because the nuclei which is there of the uranium is not able to catch it. So the moderator increases the efficiency by moderating the speed of the neutrons, and thus it leads to a self-sustained reaction. That's how it leads to a self-sustained reaction. So these are the three main important things of the controlled chain reaction. Now, in this video, we have seen about the nuclear fission reaction first. Then we have talked about the differences and the features between the uncontrolled and the controlled chain reaction. And lastly, the controlled chain reaction, we have seen the important necessary parts. We'll be back again with another video. Thank you.